In this video, I want to talk about the leading coefficient of 1 trinomials and how to factor them. This is going to be our second most important tool to be able to factor polynomials, trinomials. So this is a really important one. So what am I talking about polynomials? Well, something like ax squared plus bx plus c, where a, b, and c are real numbers. A, b, c are in the real numbers. Well, for this video, I want to talk about where a is equal to 1. So we're only going to worry about x squared plus bx plus c, where b and c are real numbers. And most of these examples, we're going to talk about when they're integers. Okay? Well, if you have a problem that's in this form, then I claim you can use the leading coefficient of 1 technique, and you can find numbers. You can break it up as x plus p times x plus q, where p times q are going to equal this c here, and p plus q equal b. So we have to think of numbers that multiply to c and add to b. Okay, let's look at some examples. It'll seem easier after we do some examples. All right, for the first one, we have x squared minus x minus 6. Now, is this a leading coefficient of 1 problem? Well, yes, because I have a leading coefficient of 1. So I'm just going to write like a cursive L here. That's a leading coefficient of 1. Now, okay, if this is a leading coefficient of 1, then I have to find factors of negative 6 which add to negative 1. Well, what are the factors of 6? 1 and 6, 2 and 3, 3 and 2, 6 and 1. Okay, well, will any of those work? I think 2 and 3 or 3 and 2 will work. Let's try those. Now I need them to add to a negative number, so I'm going to pick negative 3, because negative 3 plus 2 equals negative 1, and that's what that b term is. All right, since I've identified that the factors are negative 3 and 2, I claim that we've already solved the problem. It would be x minus 3, x plus 2. And this is fully factored. Now, for yourself, for your own studies, you can redistribute this and check and see that these are equivalent. That if you redistribute this, you'll get this back. But now this is fully factored. Okay? And in the next example, we have x squared plus 5x minus 14. So is this a leading coefficient of 1 problem? Yes. The coefficient here, the leading coefficient is 1. So this is definitely a leading coefficient of 1 problem. Then I need to find the factors of negative 14 that add to 5. Okay, well, what are the factors of 14? 1 and 14, 2 and 7, 3 and, well, there's no factors of 3. So I guess 7 and 2 and 14 and 1. All right, well, which ones would have a difference of 2? It looks like 2 and 7 would work, but I need them to multiply to a negative number and add to a positive number. So I'm going to pick negative 2 and 7, because if I add these, I get 5, which is what I need it to be. All right, so I claim that now that we have the factors, we've solved the problem. So I have x here, minus 2, and 7, plus 7. Okay, well, I claim that if you redistribute these, like we did in the previous section, that you will get this answer back. Okay, and that's what we're saying. We're factoring. We're distributing backwards. Okay, let's look at the next example. X squared minus 2x minus 24. Okay, in this example, is this a leading coefficient of 1 problem? Yes, it is. The leading coefficient is 1. So we should be able to find the factors of negative 24, which add to 2. Okay, well, 24 has many more factors than the previous examples we've had. 1 and 24, 2 and 12, 3 and 8, 4 and 6, 5, no, 5 doesn't work. And then we're going to go back down to 6 and 4, 8 and 3, and 12 and 2, 24 and 1. Okay, well, which one of those has a difference of 2? How can we manipulate that so it works? I think 6 and 4 are going to work. I need them to be opposite sign, and I need them to add the sum of them to be -2. So I'm going to make the bigger one negative, and that makes this -2. Okay, so I think we've got the answer. X minus 6, x plus 4. Okay, I claim this is the final answer. So if you redistribute this, you'll get this original trinomial back. Okay, so we've factored this. Looking at the next example, we have x squared plus 12x plus 27. Okay, is this a leading coefficient of 1 problem? Yep. Okay, so we have we need to find the factors of 27, which add to 12. Okay, well, what are the factors of 27? 1 and 27, 2 and, well, it's not even, so not 2. 3 and 9. Well, is that going to work? Yeah, that would work. So 3 and 9 works, because if you multiply them, you get 27. If you add them, you get 12. So it looks like we've identified it. X plus 3, x plus 9. Okay, if you redistribute this, you'll get back the original trinomial. So this is factored. All right, for my final example, I'm going to use x squared minus 10x plus 16. Is this a leading coefficient of 1 problem? Sure is. The leading coefficient's 1. So I need to find the factors of 16, which add to -10. Well, what are the factors of 16? 1 and 16, 2 and 8, 3 and, I'm not sure about that, 4 and 4. 5's not going to work. So what could we do? 8 and 2 would work. Yeah, 8 and 2. Then we want it to be negative, but we want it to multiply to positive. If I made them both negative, they would add to -10, and they would multiply to a positive number. So I think this is x minus 8, x minus 2. Okay, so I think this is fully factored. All right. Well, I hope this helps. And check back for the other video, which is going to be factor by grouping. And I'll see you soon.